Okay, the last subject we're covering here in Module 2 is called displacement diagrams. And all the displacement diagram is it is going to be a graphical plot of follower displacement relative to the driver. So we're going to create a chart. So on the x-axis, we're going to see the driver displacement in degrees. So that's going to be our horizontal axis. And vertically, that's going to tell us how far did that follower move. And that's going to be in inches. So if we look at in chapter 4 here, section 412. So we've skipped a couple sections again. The last section here in this chapter is 412, and this specifically looks at an example going through the process of creating this displacement diagram. So if we look, we turn the page. So this starts on page 98, this section. And if I turn the page one more time, the displacement diagram they're referring to, what it looks like is what we see here on page 100, figure 441. You'll notice here that this is a chart, okay? So it's just a curve that's created where we've got the crank angle on the horizontal or the x-axis here. And you'll notice that this is in degrees. So for the crank to go around, we know that one complete revolution is going to go from 0 to 360 degrees. And that's what they have marked off on that x-axis, okay? On the y-axis, this is going to be your piston displacement or whatever your output is. In this case, the example that we're going to be working, which is going to be example 411, it is going to be an actual piston. But if it is something, different, maybe it's blade displacement, you would put that as your label. And then this is going to be in units of displacement. In this case, it's going, or in distance, it's going to be in inches. Okay. So if we go back, you're going to notice that this is our piston arrangement that we're going to be working with in this example. Okay, now this example might look kind of familiar to you. Most of you, if not all of you, have gone through computer programming. Some of you have had me, some of you have had Ryan. Okay, and I think Ryan uses this very same example. Okay, so what I want to do is shift gears just a little bit, and I'm going to go back to our module learning plan. And you are going to notice in our learning plan, there are two additional elements here. One is a handout. This is going to be inline slider crank handout. And then the other one is an Excel spreadsheet. Okay. I'm going to look at our, actually both of those. I'm going to download both of those, and I encourage you to do the same. Okay. And if I go into my downloads here, I'm going to pull up my inline slider crank Excel spreadsheet. Okay. So in computer programming, you would have created a similar computer program or an Excel spreadsheet. Now, I've created this for everybody, and you can use the one that I have here. But if you wanted to kind of dig out yours, that you have, it will be the exact same thing as long as you got the correct results. And I anticipate that you did. But you can use mine here because then this is you're ensured that this is the this is a correct, good working spreadsheet. Now, what we have on the spreadsheet here, you're going to notice on the left-hand side here, this creates a displacement diagram for an inline slider crank mechanism, okay? It's also using the same designations for the links as we've been using here in our previous examples. So L2 is going to be the length of link number 2, which would be the crank. Okay, L3 is going to be the length of the connecting rod or the connecting link. Okay, and I'm just going to zoom in here a little bit. So one of the inputs that you have is you need to input how long is link number 1 and how long is link number 2. Now, in the example in our book, example 411, the length of link number 2 is actually 0.75. Okay, so we're just going to put in 0.75 and then enter. And then the length of link number 3 is 2 inches. So 2, enter. All right. Now, what you're going to notice is that it automatically calculates for us the stroke. Okay, so the difference between the highest point and the lowest point. All right. And so our stroke in this case is going to be 1.5 inches. Okay. So when we get to, our diagram and we figure out the high and the low values, we should get that to match up, okay? Over on the right-hand side, as we move to the right here, you're going to notice that we have a table. The table is going to take crank angle, all right? Delta is going to be displacement, okay? And that's going to be displacement from what we're going to be identifying as our 0 degrees. Then you're going to notice that we have another angle. This is an intermittent angle. We have a y distance, and then we also have an alpha, okay? These have to do with the calculations that were used in order to create our, if you would, our delta. This number right here, this delta, is the displacement that we are interested in, and we'll see the dimensions here in just a bit. And then as we move a little bit more to the right, the Excel spreadsheet creates for us the displacement diagram. I'm just going to kind of zoom out here a little bit so that we can see this fully. Let me try to do that again. Oops, there we go. You can see that it creates for us a, what did I do here now? I didn't want that. I just wanted the regular, sorry. It creates for us our, I don't know why it's putting this in here. I think it's just the graphics. It's creating for us our displacement diagram, and it shows it from that 0 degrees all the way to 360. And then our piston displacement in inches is going to be on that y-axis. Okay. So it takes the information over here and then it translates it into the displacement diagram. So we want to be sure what we're going to do is we're going to do our example. We're going to move our crank around, and we're going to verify some values or placements on this Excel spreadsheet that we created. Now, in addition to this, there is also the other handout. So I want to go back to, I'm going to minimize this. Go back over here, and in my downloads, you have that inline slider crank model. Now, I'm not sure if you had me for computer programming, you probably remember this handout. If you had Ryan, I'm not sure if he used this very same thing or not. But what this does is this corresponds the distances to that spreadsheet that we just looked at. Now, these are different values. In our case, in our example 4.1, we have a crank that has a 0.75 and for the crank diameter or for the crank length. And then for our link number 3, we have a length of 2 instead of 3. So the values here are different, but the process that it goes through is exactly the same. So first of all, you're going to notice that in the first illustration here on the left, we have the crank completely vertical and link number 3 completely vertical and in line with the slider. Okay, so this would be what we would call the highest limiting position or extreme position of this mechanism. Now, in the case of the cylinder in a piston bore, we would call this top dead center. Okay, that's the highest position that's going to be. Okay, and then you're going to notice that if we go to the one all the way on the right, you will see that here we have the position in what we would call the bottom dead center. This would be the lowest extreme position of this mechanism. Okay, so over here, this is where we see that link number 3 overlapping with link number 2. Okay, so it's going to be its furthest point down. And then over here, these are extended in line with one another. Now, the positions in between then are the ones that we kind of hit before we get from one to the other. So you'll notice that our second position here is rotating our crank counterclockwise 45 degrees. Okay. And then noticing from that top dead center, that furthest away extreme position, how far did we actually move? And in this case, notice that's that delta, that's the displacement. So that triangle looking symbol is called delta. It's a Greek symbol. And typically in engineering, we see it for a change in. And in this case, it's a change from that top dead center to the new placement when I move the crank 45 degrees. Okay, so it went down 0.377. Okay. Then you're going to notice that here, if you move it another 45 degrees or 90 degrees from that original top dead center, it's going to have a delta from that 0, if you would, down to 1.172. And then another 45 degrees, we're going to be again a little bit more. And then when we are over the top of one another, this is going to be the position at the bottom dead center, or the second extreme position in its lower position. And that's going to be a total of 2 inches. Now, because this is an inline slider crank mechanism, if we go back to Excel here, that just means that our highest point is going to be that placement at 180 degrees, and it's a mirror image on the other side. Now, if I put these values back to what that example is, where it's 1 inch on our L2 and 3 inches on our L3, then you're going to notice that these same values are going to match what was there. So if I go back to here, if I go to 45 degrees, my delta should be 0.377, okay? So going back to my Excel spreadsheet, and if I go to 45 degrees right here, that's this one. Sure enough, my delta here is 0.377, okay? So what I want you to do is you are going to use this spreadsheet to kind of get your answers, okay? And then you're going to then move your mechanism around to make sure that they match, okay? That's really what you're going to do. So we're going to use example 411 for the process that you're going to use for your homework problem, okay? So any questions kind of how this spreadsheet works? And again, all of you should have, how many people have had computer programming? Perfect. Okay. Joseph, have you? You haven't had it yet, or that Excel? Okay. All right. But does this make sense? Do you have any questions? Okay. All right. So, we're going to keep this in the background here, and we're going to go over to underneath our camera at our example and kind of see what we're supposed to do here, or what the problem is that they want us to complete. So first of all, it says for 411 in figure 438, which is going to be up at the top of the page, we have a mechanism of a reciprocating compressor. Plot the displacement diagram of the piston displacement relative to the crank rotation. Okay, so here again, we kind of glanced at this earlier. Here is our frame. They're calling this the crankshaft, or what would be the crank, which is going to go around. Connecting rod, and then this is our piston that is constrained to only moving vertical. Okay, so this is the arrangement we have. In this case, we have a crank length of 0.75. And we have a connecting rod length of 2 inches. So step number 1 is going to be creating the kinematic diagram for this arrangement. So what I want you to do is we're going to, in AutoCAD, draw our base arrangement here for this compressor mechanism. I am going to just pause the recording here, do my CAD work in the background, and then I'll resume once we're all set, and then you guys can do the same on the side here. Okay, now that I have kind of my diagram started, I left kind of some of my labels off just because I know we're going to be moving this a couple different times. And instead of having to kind of fight where those are and move them as I go, I'll kind of put them in at the end where we've got room. So the things that are important here are going to be the center of rotation for our crank, which is going to be A. Then we've got the end point of what would be link number 2, which is our crank, which is going to be B. And then we also want the center of our slider, which is going to be our point C. And then as we know, our slider would be link number 3, or I'm sorry, link number 4. And then you would normally have a D in here. But because we're going to be kind of moving things around, again, for the sake of just not having to continue to move other elements, just kind of keeping it simple for right now, and we'll add these back in at the end. Now, the position that we see this compressor mechanism in is its top dead center, or what we're going to be using as our 0 degrees, our home position. So when we do displacement diagrams, the first thing we want to do is we want to determine what are the extreme positions. And one of them in this case is going to be when we are stretched all the way up and this is in its highest position. And we know that to be the case here. If you don't have that information, you need to find that first, okay? So for instance, for early examples, we usually are given kind of a random place in the cycle. And if you don't know, if you know that that's not one of the extreme positions, you need to find that first and then assign that as, if you would, 0 degrees. So I'm going to draw a line on my 0 layer. And that line is simply going to be a horizontal line. So I'm going to put my ortho on, and I'm just going to draw at a random length. And that's going to be where all of my dimensions come from. Okay, so my displacements are going to come from the 0 degrees, and we're going to then show them, where the new placement is from that 0 degrees. The next one that I want to do is going to be that lowest point or bottom dead center of this piston arrangement. And to do that, I know that the radius that I would strike along this line of action is going to be length number 3, which in our case is 2 inches, minus length number 2, which is 3/4 of an inch. So I am going to draw a circle center radius that is going to have a center of A, but this one is going to be 1.25 radius, okay? That is going to be the furthest down position of our slider, okay? So now what I'm going to do is I don't even know if I'm going to do the dots because they're going to get kind of big here. So I am going to draw on my object 2 line, where I am going to go from the center of what would be from 1 to that placement right there. I'm going to have to put a dot because it's right on the line. That's why. So we'll copy our pin connection here to the intersection that was created. Here again, see, we end up moving things around. So this is going to be actually the end of link number 3. So this is going to be we're not going to do primes for each of these except for the extreme positions. So we're going to call this C prime because this is the bottom dead center and C is the top dead center. Okay. And then we would need to show that link number 2, or I'm sorry, that object line 2, straight line going down to the quadrant of the 0.75 circle. Quadrant there. Okay. And that would be B prime, because that's going to be the lowest position for that B prime. Okay. So that's overlapping. So C is the highest position. C prime is the lowest position of the slider. I'm not going to redraw the slider because we're going to be doing intermittent placements here, and it's just going to be lines over lines over lines. You'll see in just a bit, it'll kind of make sense. Now, what I want to do is I want to add the dimension. Okay, so I'm going to go on my notes layer, and I'm going to add a linear dimension from the center of C to the center of C prime. Okay. And I'm going to put that dimension kind of all the way out over to the left because we're going to be adding intermittent ones. Now, this represents the difference between the highest extreme position and the lowest extreme position, which is our stroke, okay, which is our stroke. And if we look in the book, the stroke is 1.5 inches, okay? So that confirms that we drew everything correctly. If you get something different than 1.5, then maybe one of those distances aren't quite right. Okay, so you'll have to go back and check that. All right, so that's kind of the highest and the lowest. Now what we want to do is we want to change the position of the crank to be in a couple different locations. And the first location we're going to do is we're going to rotate that crank 45 degrees, okay, 45 degrees. So what I'm going to do here is I am going to try to select the line that goes to B, but I probably, oh, there it is. So you'll notice that my original, right? Doesn't look right. Well, what I'm going to do is I am going to turn off my object 2 layer for right now. Okay. And oh, I drew it as a line. So all I'm going to do is I didn't split it up into 2 lines. I'm going to go back to, we're going to use object 3. And I'm going to draw a line from the center of A to the center of B to just represent the length of link number 2. And now I'm going to rotate this 45 degrees. Okay. So we're going to do a rotate. Make sure you select that line that you just created. Enter. The center of rotation is going to be point A. And we're going to rotate that 45 degrees. Okay, so you should be out like this. Now, this would be the new position, if you would, of B. We're not going to label it B prime prime because we're going to do like 3 more of these. And it's just going to get, too busy. And that's okay. All right. But now what we want to do is we want to go from that position. Where would it cross over that vertical line of action of that slider? So I'm going to go back to my 0 layer, circle center radius from the end point that I just created right down here. That's the center this time. And the radius I'm going to have is going to be 2 inches because that's the length of link number 3. Notice that it crosses the vertical line, okay, right here. So that means using my object 3, I'm going to draw a line from the end point of that 45-degree angle to the new position that crossed that vertical line. That makes sense to everybody? Okay. I'm going to get rid of these 2 radiuses. Actually, all 3 of them. Okay. And now what I'm going to do is I'm going to go to my notes layer and I'm going to draw a linear dimension from the center of the original C to the end point that I just created. Okay. But I'm going to move this dimension so it's like out of the way here. That's my first value. Okay. Now I'm going to go back to my spreadsheet and I'm going to find out what is the number for the displacement at 45 degrees when I have my crank at 0.75 and my connecting rod at 3. So I have to change those dimensions. So I'm going to change my L2 here on my spreadsheet to 0.75 to match what I have in my example. And my L2, I'm sorry, my L3, the connecting rod is 2 inches long. Okay. And if I go here to my crank angle of 45 degrees, my spreadsheet says I should see 0.291. Okay. If I go back to AutoCAD, sure enough, I have 0.291 is my number right here from top dead center to my new location. Okay. Now I'm going to move another 45 degrees. Okay. And I'm going to get that same dimension. So I am going to rotate my crank. Okay. And I'm going to go up to rotate. I have that selected. Enter. It says to specify the base position. That's going to be point A. Now, remember, I want to leave behind a copy. So I have to do C, enter. And then now I want to rotate that another 45 degrees. Don't put in 90, put in 45 because it's from that position. So 45, it'll be now at 90 degrees if you would. And then now I'm going to go back to my 0 layer and I'm going to draw a circle center radius. The center is going to be at the end of that point. And then I'm going to draw a radius of 2 inches, which is the length of link number 3. It crosses that vertical line right here. So I'm going to change my object. I'm going to add, if you haven't done so yet, you want to add another object layer. Okay. I made a yellow layer still with the dashed line. So if you need to go to your layer properties, click on, if you would, object 2 or 3, enter, and just change the color, making sure that your line type is hidden, okay? So I'm simply going to change the line type from that line that I just rotated to object 4. Make sure that your current layer is object 4. And then I'm just going to connect my line from the end point of my crank to the intersection that just was created on that vertical line. Okay. Now here again, I'm not going to put the C prime prime prime, and I'm not going to put the dot for the pin connection because it would get, crazy and busy. Okay, so now what I can do is I am going to go back to my notes layer, and I'm going to do another linear dimension from the center of C to the endpoint of what is my yellow line this time. Okay. And this one I'm going to put up in the middle here. I've got 0.896. Okay. So if I go back to my spreadsheet, this is going to be the 90 degrees from 0, because notice that my yellow, if I measure from 0 degrees when this was vertical to where it's at now, it's 90 degrees. So back at my Excel spreadsheet, I'm going to go down. I'm going to find where 90 degrees is. And you'll notice that I have 0.896 on my spreadsheet as my delta. Back over here, 0.896 is my AutoCAD value. Pretty good, right? And that's why using AutoCAD is important. We can see that we get really good accuracy here, okay? All right, the next one we're going to do is going to be rotating another 45 degrees. So I am going to go to my rotate command. I'm going to select that last crank that I had, hit enter. The rotation point is going to be from A. I want to leave behind a copy. So you want to hit C, enter. I think I hit my mouse. So let me do that rotate again. Rotate, select, enter. Base position is at A. C, enter to copy. And I'm going to do another 45 degrees. I'm going to change this color to object 5. And again, you can pick colors as long as you can see the difference. All right. And then I'm going to change to object 5. All right. I'm going to get rid of my construction circle from before. I'm going to put my construction circle back on, sorry, my 0 layer. And I'm going to do my circle center radius from the endpoint of that new crank position. And I want the radius to be 2 inches, which is going to be right there. It crosses. Okay. So I'm going to go back to my object 5. I'm going to go from that intersection down to the end point of that crank position that I just created. Okay. And then now I'm going to do another dimension, a linear dimension from C to my new position right here. Make sure you grab the right point. And that's going to be 1.319. This would be to 90 plus 45. I think that's 135, right? So I'm going to go back to Excel. I'm going to kind of get this on here so you can see it. I'm going to go back to Excel. And if I go down to 135, 1.352. Go back over here. 1.3519. It would be 1.352 rounding to 3 decimal places. So that is correct. And then the last one that we have, I'm going to put it back in. I think I deleted it somewhere along the way. I want to change that to object 2 and just make sure you might have yours in there. Mine went out. This is just going to be line from here. Oh, object 2 is off. That's why I turned it off. That's why it's not on there. There we go. And then you'll notice that object 2 is there. Now, you do not need to put in all of the dots and the positions along here, because again, it just gets too close to try to put the values in there. What we do want to add though, is we want to get rid of this construction line. I'm going to scooch my 1.5 closer. Okay. And then I want to add the labels in that aren't here yet. So I'm going to move my number 1 to where the frame is. I'm going to move my number 2 over about here, what you can do. Number 3, kind of the same thing. Number 3-ish right about there, because there's too much busyness over here. Number 4, let me scooch this over. Number 4 is my slider. And again, use your best judgment. And then for the placement, and then D is going to be here. And then I've just got to move this over, and over. And I think that should, it's a little close, but that's okay. All right. Now, this is showing us what are intermittent values along the way to what would be 180 degrees on our diagram. Okay. So if we go look back at our Excel spreadsheet, as we know, if we look here, our highest position was 1.5 inches. We don't see that actually over here, but it's right in the middle here. That would be 1.5. And if we look over here, our highest value, we should see 1.5 right here at the 180 degree mark on an inline. Okay. It also is going to be the value that we see as the stroke. Okay. Now over here as well, you'll notice that starting at that 0, because it's an inline, it's going to be a mirror image on the other side. That's why I don't have you guys worry about adding more rotations on the opposite side, because it would be the mirror image. Does that make sense? Now, if you create your diagram here and your numbers are not coming out, then something in your original layout does not match the numbers that are there. Okay. All right. So for handing in here, you are going to take a screenshot of this diagram. So you would do your screen snips. We would go around this area and we're going to go back to our document and add, I'm assuming that this is towards the bottom. So I'm going to insert a page break. This is example 411, and then I'm going to put my screenshot here. Okay. Now, these values are going to tell me that you did it correctly. So I'm not, for the practice problems, I'm not going to worry about screenshots of the Excel spreadsheet. Okay. You don't have to worry about that, because if you got these same numbers, I know you're correct. Okay. For your homework though, I'm going to have you hand in the file you're going to attach that you changed to match the numbers that are in the book, which then your diagram is going to have to line up with those numbers as well. Does that make sense? And we'll talk about that in more detail. Aiden. Okay. Yeah, I'll talk about that in just a bit. But for our practice problems, for example, 411, you just need this diagram, okay? Just to kind of keep it simple, because we all kind of looked at that Excel spreadsheet. Okay. No hand calcs on here. Nope. Just the graphical solution, and your screenshot lets me know that you did that correctly. So then what you can do is you can save this. You can file save as your practice problems. And then this is going to be the file that you hand in for the practice problems. So let's take a real quick peek at the practice problems to be sure we've got what we need. So if I go back to module 2 and I go to the practice problems, okay, you have example 4.1, 4.2, which we did last time. Today we did 4.6, 4.7, and 4.11, okay? And then, like I said, you don't need to worry about the Excel spreadsheet or the file for the practice problems because we kind of looked at that together, okay? And then don't forget to answer the 2 questions that are here as part of your Word document. Make sure that you tell me what are the 2 things that you learned here in Module 2, and still maybe a couple things that you feel like you need a little bit more confidence on, okay? Now, then you'll just hand in that document for the practice problems that we just worked on. If you need to put some finishing touches on those during our lab time, you're welcome to do that. And I'm happy to come around and help you with any adjustments that you need to make if you're seeing any discrepancies, okay? So any questions on kind of content and practice problems at this time? Okay, then I'm going to stop the recording here.